FastMCP 3 introduces a file system-based component discovery mechanism through the FileSystemProvider, enabling automatic registration of decorated functions without explicit server coupling. This provider pattern implements a directory scanning abstraction that maps Python files to MCP components, eliminating import coordination between server and tool definitions. We'll examine how the server initializes with a FileSystemProvider targeting a local directory, demonstrating the minimal setup required for automatic component discovery. The configuration establishes a root path relative to the server file, preparing the provider to scan for decorated functions during startup.
From passlib import path. From FastMCP, import FastMCP. From FastMCP server providers, import FileSystemProvider. MCP equals FastMCP my server. Providers equals FileSystemProvider path file. Parent / MCP.
This code demonstrates FastMCP's file-based component discovery pattern using FileSystemProvider. The pattern eliminates the need for explicit component registration by automatically scanning a directory for Python files containing decorated functions. This approach decouples component definition from server configuration, allowing developers to add new tools, resources, or prompts simply by creating appropriately decorated functions in the designated directory. The implementation works by creating a FileSystemProvider instance that points to a specific directory, pathfileparent / MCP, which is then passed to the FastMCP server constructor. During server initialization, the provider recursively scans all Py files in the specified directory, importing them and registering any functions decorated with @tool, @resource, or @prompt. This creates a clean separation of concerns where component files don't need to import the server instance, and the server doesn't need to explicitly import component modules. This pattern is particularly useful for larger projects where you want to avoid circular imports or maintain a clear organizational structure. The trade-off is that you lose some explicit control over component registration, relying instead on file system conventions. The approach works well for development environments, especially with reload equals true enabled, but may introduce overhead in production due to the file scanning process. The directory structure becomes your component registry, similar to routing conventions in web frameworks, making it intuitive for developers familiar with such patterns. Let's break it down line by line.
From passlib import path.
Imports path from the pathlib module for cross-platform file system path manipulation.
From FastMCP, import FastMCP.
Imports the FastMCP class from the FastMCP module, making it available for creating MCP server instances.
From FastMCP server providers, import FileSystemProvider.
Imports the FileSystemProvider class from the FastMCP server providers module, which enables automatic discovery and registration of components from Python files in a specified directory.
MCP equals FastMCP my server. Providers equals FileSystemProvider path file. Parent / MCP.
Creates a FastMCP server instance named myServer, configured with a FileSystemProvider that scans the MCP directory located in the same folder as the current file for Python files containing components. The server identifier, myServer, will appear in protocol handshakes to help clients identify this server, while the FileSystemProvider enables automatic discovery of tools, resources, and prompts from the specified directory without requiring explicit imports or server references in the component files. The FileSystemProvider pattern in FastMCP 3 decouples component registration from server configuration by treating your directory structure as a component registry. By pointing the provider at a local directory, you enable automatic discovery of decorated functions without requiring explicit imports or server references in component files. This creates a clean separation where components become self-contained files using standalone decorators, while the server remains unaware of their specific implementations. The trade-off is explicit control for convention-based simplicity. You gain rapid development and intuitive organization at the cost of some runtime overhead from file scanning. The pattern particularly shines in larger projects where circular imports become problematic, or when you want component files to remain agnostic of the server instance. The directory-based approach mirrors routing conventions in modern web frameworks, making it immediately familiar while maintaining FastMCP's provider-based architecture under the hood.
The decorator whispers to the function. The provider traces the path, but the server still hunts for tools already nestled in its lap.